Here we are in the second lecture of Module 4, the module about classes and objects. And as a reminder, here are the two module learning objectives we have for this module. And we're really still working on the first of those two learning objectives. Last time, we learned the conceptual ideas behind the object-oriented paradigm in general, and we learned some C# specific terminology about how we deal with classes and objects. This time, we're going to go beyond the terminology and actually start using classes and objects in C#. So the first thing we're going to need to do if we're going to do an object-oriented program is we're going to need to know how to instantiate an object from a class. Of course, that means you have an in-lecture quiz to handle. When we need to start interacting with particular classes, we need information about those classes. We need to know how we, as consumers of that class, can interact with it. And guess what? The way we learn that is through documentation. You will spend lots and lots of time reading documentation to understand how to interact with classes and the objects we create from those classes. This particular slide shows some documentation for a deck class that I wrote. You'll notice that it is in the Lab 4 class library. So if you decide to go do that optional Lab 4, this is where this documentation comes from and where the class comes from. But you should also know that this documentation did not just magically appear. I generated this documentation using the documentation comments, those 3/ comments we put above classes and methods and properties. So this actually is generated because I did the documentation comments, so it was easy to generate, and it makes it so that consumers of the class can actually use the class, which is good. Programmers need to know how to use the tools we provide to them. So this is documentation for the class, and the heading here says deck members. Deck members are really all the constructors, which is how we instantiate instances of the class. We use a constructor, and the methods and the properties of the class. It can also include the fields if we made them publicly available and so on, but we tend to exclude those from the documentation because they're hidden. That's the information hiding thing. So we've got this documentation, and if we want to know how to instantiate a deck object, and that's going to be the example for today, then we need to be able to use the constructor. And to know how to use the constructor, we actually have to look at the constructor documentation. So I clicked on the deck link to get to information about the constructor. And here's the information you're going to care about. The constructor is public in this case, which is great, because if we can't actually access the deck constructor to create a new deck, that is useless to us. Later on, more advanced programming, you'll discover that constructors aren't always public. But for this class, the constructors will always be public. We know that the constructor's name is deck, and that will always be the case. The constructor will always be the class name. That's just always going to be the way it is. And the last thing we see is right here, hard for me to get it, I think, but there were a couple of parentheses there, and there was nothing between them, which means when we call the constructor, there's no information that we need to provide to actually use the constructor. Okay, so let's actually get started. I'm going to open up a project that I already created just so that I could include the deck class and have that already built in. So let's go to that now. So I've opened up this project. It's a console application that I called using deck class. You'll notice that it is a console application, and I've added some comments, and I'll zoom in so you can see them. I've added some comments about what the program is all about and what the main method is all about, including command line args. So First thing we want to do is we want to create a deck object. The way so we have to declare a variable just like we did with value types. So we know that that started with the data type, followed by the variable name, followed by optionally assigning a value to the variable. And so that's what we're going to do here. So your first question is, what's the data type? Well, a deck of cards is definitely not an int, right? A deck of cards is not a whole number. It's, and it's not a floating point number either, nor is it a single character. So it's none of the value types. Remember I said that classes are basically their own data types. So the data type we need for an object of the class deck, the data type is deck. Now we need to give it a variable name, and I'm going to call it deck. Remember, C# is case sensitive, so lowercase d in the deck makes it different from capital D in the deck for the class name. So this declares a variable. I am going to right now use the constructor to actually create a new object. The way I use the constructor is I say new. That's a special word in C#. You can see it turned blue. It's a keyword. I'm saying give me a new object, and then I tell it the class name. It's deck. And just as there were parentheses in the documentation for the deck constructor, I need parentheses here. So I'm going to also, knowing I'm going to want that blank line at the end, I'll add it now, like so. And so I've created a new deck, and if I run this code with Control F5, it's not very exciting at all. It just says press any key to continue. Good news is it didn't blow up and break, so we can infer that it actually created the deck appropriately. So that's how we use a constructor. We just say new, and then the name of the class we're trying to construct, and then we put the parentheses. And if it required us to pass some information, we would. And we're going to see an example of passing information to a method next time, but not this time. We don't have to worry about passing any information. So I've created this deck object. The next thing I want to do is I actually want to find out information about the state of the deck. And so you should do an in-lecture quiz to see if you remember, because we talked about this last time, if you remember how we get at the state of the deck from outside the deck. Going back to our documentation for the deck, we can see that we already looked at the constructor here, and we can see a listing of all the properties that the deck exposes. And there's only one. It's empty. And so this property will tell us whether or not the deck is empty. To get some more details about this property, I clicked on the empty link. And when I did, I got this documentation. And this documentation tells us a couple of different things about the property. First of all, it tells us that the property is public. That's good news because we want to access it from outside the class, so that's great. It tells us that this property is a bool, and we are familiar with bools. We know about bools, they're true or false, which makes sense for finding out whether the deck is empty or not. That's a true or false thing. And the last thing we see is that we can get whether or not the deck is empty, which is what we'll do here, but we can't set whether or not the deck is empty. So we can find out if it's empty, but we can't say to the deck, hey deck, you're empty. I don't care how many cards you have in you, I've decided you're empty. So now we should look at the actual syntax for accessing this property, now that we know that it's a bool property and that we can get this information. So back to our environment. Print deck empty information. So I'm going to show you two different ways we can do this. The first is to have a Boolean variable that we declare here. We can call it isDecEmpty, and we're going to assign a value to this variable. And the value we're going to assign is finding out whether the deck is empty. So we're going to access the empty property. Before we do, the first thing we need to do is put the name of the object we care about. Again, here's an example. So I'm in a classroom and I say, "Are you hungry?" Which student do I mean? Everyone's going to yell out something, right? And probably, "Why didn't you bring us food?" But I'm going to need to talk to a particular student. Not that I think of my students as objects, but a student object, and say, "Are you hungry?" And so similarly, I need to know whether a particular deck is empty. Not sort of all the decks in the universe, but a particular one. Luckily, I have a deck object right here. So the first thing I do is put the object name. Just like I would say, "Joe, are you hungry?" or "Mary, are you hungry?" I'll say deck dot, and then I access the property. Now, when I access properties, I just put object name dot property name, and that's it. And then the semicolon that I'm putting at the end of every line of code I write in C#. Okay, so that's how you access a property. Now that I have stored that information into the isDecEmpty variable, I can print it out with a console write line. Like so. And when I run this program, it comes back and says empty is false. The constructor for the deck, you don't know this, right, because it's internal to the deck, but I can tell you, because I wrote the deck class, that the constructor for the deck generates 52 cards and fills the deck with them. So we can find out whether the deck is empty by accessing that property, the empty property. Because we're not really doing anything very interesting with this deck empty property, it feels kind of wasteful to declare a variable to hold it. So here's a shorter and still very obvious way to print out the same information. Instead of accessing the property and shoving it into a variable, we can just access the property as part of our console write line. So if I Control F5 again, we see exactly the same behavior that we saw before. I'm going to save all. And that's it for what we're trying to do today in C# code. We used a constructor to create a new object, and we used a property access to get access to the state of that particular object. So we've already practiced with constructors and properties. Next time, we'll take a look at methods and start using a couple of different methods on the deck object to actually access the deck's behavior.